Hey guys, this is Mr. Waltz. I'm going to show you how to do circuit 6 here, which is the parallel LED circuit. So, take your previous circuit, circuit 5, make a copy of it. And then that's always a good way to start. So we're going to use the same 3 LEDs, but we're going to change how they're connected. So the basic arrangement we want here is we're going to get rid of these little jumpers. Keep that resistor. And then the easiest way to do this is to take the LED here, the red LED, put it into row 2 and 3 into the E holes, okay? And then I'm going to do the same with the white LED right below it and the blue LED right below it. And so in a parallel circuit, you got to connect each branch to the positive and negative rails, okay? And so what we're going to do is for the red the red LED, we've already got the red wire from the power supply that brings your positive voltage to the rail. The resistor carries that positive voltage to row 2, goes into the positive terminal, the anode of the red LED. And then we have the cathode, the negative terminal. And what we want to do is connect that negative terminal back to the negative rail, okay? And so basically it's just a bunch of separate circuits is what it really is. We have one LED circuit here, and then we want to make another one down here and another one down here, okay? And so you can just copy this resistor, put it there, make another black wire, and then copy it again, Control-C, copy, Control-V as in Victor to paste. Make sure when you put the LEDs in that they're going to the positive on the left and then into that row that your positive terminal, your LED is in. And then another black wire here. And so now things are looking good here. I got everything wired up. That's a parallel circuit. There's other ways to do it. This is just a really easy, quick, easy, and it doesn't take up much space on the breadboard if you do it this way. So then you want to start your simulation and see what happens. So you'll see the LEDs come on, and unlike the previous circuit, the series circuit, the LEDs are at their full brightness. And if you put your mouse on them, you can see it says, hey, this is at 21 milliamps. So these guys are getting their full brightness. And the reason is that they're all given the full voltage of the power supply because they have independent connections. They're not sharing the voltage anymore. So when those electrons arrive, they have their full energy, and they are able to make more current flow through the LEDs. Now, look back at your power supply. You can see your power supply has almost 63 milliamps. And so that's I guess that would be the negative side of this, is that because those LEDs all have more voltage now, they're pulling more current, and they each have their own circuit. So instead of sharing one circuit, they're each pulling their 21 milliamps or so off of here. So it adds up more. So they use a lot more power, but they are a lot brighter. One advantage of this circuit, I'm going to stop the simulation. Let's say that something bad happens and one of your wires gets deleted there or breaks or something. If I turn this back on, everything will run except for the one that's broken. So this is an advantage of a parallel circuit, is that if one branch of the circuit fails, then you're okay. Okay, so that's the point there. I'll put that back together, and then just remember when you're done, start the simulation. Make sure you can see your current reading and everything, and that the LEDs are lighting up, and then take a snapshot and turn that in on Classroom. Okay, peace.